All right, so my name is Kuckein. I'm with Hammerspace. I'm the Senior Director of AI Marketing. And with me today, Sam.
Hi, Sam Nunham. I run our AI solutions practice here at Hammerspace. Thanks for joining us today.
And today we'll be talking about our AI data platform solution and how we integrate with NVIDIA's reference design.
Thanks, Kurt. Part of this, I think it's always important to set a little bit of the stage, right? And what we see in talking to customers every day, I assume the same way you experience in your business, or whereas you talk to customers as well. But the data fragmentation problem's real, right? I think we've heard it on 17 billion podcasts at this point, is the data readiness is still a massive inhibitor to AI. The other challenge is the tools, right? We saw an article this week that there's a major bank that kind of put up a fuss that, hey, this AI stuff isn't easy, right? These factories aren't as simple as just plugging in data and power, but there's a lot of endpoints, tooling, complexity in these workflows. And there's also a massive capital outlay that comes with this, right? Most of our customers have FOMO. They fear missing out on AI affecting their business. They have FOMO as well, right? A fear of messing up, because we're talking about massive spends that have to deliver on value. In short, you've heard a lot now about Hammerspace and in the things that make our platform unique when it comes to global namespace and tier zero. What we did is choose to package and extend this, right? Thinking about how do we really solve that data challenge for enterprises. And so the idea being, right, is we take the Hammerspace software, package that along with best of breed NVIDIA software, right? As we look at their RAG blueprints, the RTX 6000 Pro, and as we mentioned, a new MCP server that we're developing that really helps stitch this thing together. We're allowing customers now to kind of buy an outcome, not a toolkit, right? It doesn't need to be this recipe of things that have to come together. We're reducing all the tooling that happens so that a storage admin can aim this particular thing at existing data and get AI ready data within minutes of it scanning and seeing that particular file system. And it becomes extremely cost effective. We see most of our customers not building, thousands and thousands of GPUs, but they're doing project-based AI. It may be a department, it may be a certain POV or use case. And so they're trying to find ways to basically start their AI factory with what they have today. And so the idea behind this particular AI data platform is removing all that. They don't have to think about NV ingest and how do I create these NIMs and toolkits and how do I monitor and log all of this data. But we really want to give enterprises some freedom to take data where it lives today, move it through this AI process, and get to the point where applications and agents can use that data consistently and frequently. The idea being is that we deploy this integrated appliance, right? We'll talk about how this is sitting on top of Cisco, Supermicro, Lenovo. The great part about being software defined is I can run the same thing in the cloud as well. The beauty is I'm not tied to a hardware platform or some bespoke hardware. I then connect it to my enterprise hybrid data. As you heard Kurt talk about, we can do this through assimilation. That's either full assimilation, or we can do something called read-only assimilation. I can take snapshots of those other file systems and process, which is really important for RAG. We think about it, there's a portion of data that changes constantly, but as they suck in their first petabyte of data, that data has been sitting there for 2, 3, 4 years, right? We're scanning all the PDFs and product documentation, support logs, right? And so a lot of this says, why would I copy that to new, shiny, expensive flash when I could use that where it is and just accelerate it? And then we're able to automate these embeddings of pipelines. We're going to talk about how we do this a little bit. But the idea is that you don't want to have to understand re-ranker and what this index engine is and stuff. We could package all that and obscure it. It makes this much simpler, and the time to value increases dramatically for our clients. So let's talk for just a minute about how we do this. What's the magic under the covers? And so the idea is that, we can point at some other storage. It could be our storage, it could be object, it could be something. But as new files arrive, we discover those, right? This is the beauty of metadata tagging and how we do things. And so we allow storage for these files to be economical. Really think there's 2 tiers of storage. It needs to be as performant as possible when you use it, and as economic as possible when not. Like as we mentioned about the flash crunch, it's going to be very expensive to keep stagnant data on very prime flash tiers as we think about how much new data is being created in the organization every day. So as those files are tagged, we move them to tier 0, right? This is a background copy motion, right? That we can do that. We're all going to do the heavy processing, right? As we, go through the extraction process and tear all these PDFs apart and images and tables, that's all going to happen on our tier 0, right? So we're not burdening the existing systems that were designed for economic storage. Our MCP server is then the connective tissue, right? Between everything we can do as a platform, the NVIDIA stack, and the agents that need to communicate with that information. And so as soon as those files land, we instantly embed them, right? And it's not that we just run a script and hope it works. We do true validated output. We can do test cases. We can make sure all this stuff, if it got, if there was an error exposed, we retry those files automatically. Was it a locking problem? Was it a performance problem? Those type of things. And that is now fully ready for our agents and things to consume. We then automatically clean up after ourselves, right? We don't see data scientists do that very often. And then we have AI ready data. So again, simplistic diagram of a lot of complex things that happen underneath. But this is the idea of being able to really reach into file systems. The concept of AIDP says, why have to push all this stuff to a new location, to a new thing? It's already in storage. Storage knows when a new file is created. We should be able to do all this embedding and processing in the background, not as this other expensive human task on top of those platforms.
So it's Ray Lucchese. Is the tier 0 actually running in the NVIDIA server?
So great question.
NVIDIA Flash?
So it's actually, so we are running on standard servers, right? This example is a Cisco Blade solution. To my point about starting small, I can start this in a single chassis. So tier 0 is using the NVMe sitting on a C210 server. We've got RTX Pros in this particular scenario. And so we've stacked our entire software, right? The Hammerspace software, the NVIDIA software, all into a single appliance that's fully combined, scalable, and manageable in a single footprint.
So do you actually lay out a file system on the NVMe flash, or do you use it as raw block data?
No, we actually lay out a file system. So as Kurt talked about tier 0 earlier, which we can dive into, we can actually take that flash in all of those GPU servers, whether it's a cluster like this or a very wide, large cluster, and create a full tier of file system at the NVMe level inside the server, and then handle all the automatic tiering and positioning of that files as those particular jobs need it, or as those files are called to use from a Slurm scheduler or some other type of system.
What is the base file system that you lay down on the flash?
So it's Linux, basically EXT file system, right? We are all standards based. The beauty of the Hammerspace platform, right, is that everything we do is NFS, 4.2, those types of things. So we're using existing kernel resources to basically share those drives via NFS. It all mounts through our Anvil servers and gets represented to those servers as one ubiquitous file space.
So Ray, you had asked, are we taking over the NVIDIA slash?
Yeah.
And so in this case, if you're looking at a AI factory, no, right? It's a self-contained solution here in the Cisco server. In other cases, yes, we can take over the flash within the GPU cluster. Yeah. And then serve up the data directly from there. And there's even, hooks that we've built in that allow the server to recognize whether that data is actually local to the GPU or on another server within that cluster, and then be able to find the lowest latency path.
The other question might be, NVIDIA offers, RDMA over NVS and other protocols to speed up data transfer. How does Hammerspace play in that environment?
That's great. We found that normally PNFS, right, is plenty fast to saturate the GPUs in these types of environments, especially for data processing. But even as you get into B200s, B300s, the new NVL systems, those types of things, PNFS actually is incredibly performant for two reasons, right? One is because we're deeply embedded into the kernel. We can actually do things like NFS direct, right, where we can bypass the memory stack and be able to really feel like it's bus local storage, right? To think about it to those GPUs. But we're also fully integrated into GDS and those types of things as well. So if we need to perform that type of technology, again, to us, it's another protocol and method that we can serve data.
So I want a clarification on something. So is the tier 0 NVMe drive, is it then dedicated to Hammerspace, or is it still shared?
In this, it's dedicated to Hammerspace. We take over and own those drives, right? So those aren't, temporary space or scratch space or that sort of stuff within those systems anymore. We actually take over those drives and create think about almost a rated file system across those servers in those environments.
Yeah, and you already said something that was going to be my follow-up question. You said multiple drives. So tier 0, is it a minimum of 1 NVMe drive? Can it be more? Is there like an ideal setup?
Yeah, so again, this is the fun beauty of software-defined storage, right? Is that we can take 2 drives, right, that are normally populated in HGX systems. We can fully populate those systems with 8 to 10 drives, depending on the form factor of those things. So we're not limited. We can use as many drives that are in that system. And this is what we find a lot of clients do, right, is they run out of space or they run out of power. And so while it's a speed play in some cases, it's actually an economic play, because now we're already consuming that rack space and that power footprint. We can continue just to add drives and create an entire fast layer of storage directly on those NVMe servers, right? With the durability, reliability, if those nodes reboot or we take some sort of different maintenance window, there's some things we put in place from a policy perspective to protect against that. But yeah, it could be 1 drive or it could be 10 drives per server. We don't care.
I guess my question would be, what about boot and things of that nature where you don't actually have all your software deployed in the system? You must relegate some portion of those drives to, OS or something like that.
Oh, 100%. So most of these systems usually have a mirrored set of boot drives in the back, right? They've got 480s, 960s. And so that's kind of built into the platform itself, right? Is that boot in OS flow lives on those mirrored drives. The drives in the front of the system are dedicated to data. So for the sake of time, I want to push a little bit, and I know we can continue to dive deep, right? Any good seller wants the second meeting. And so I think we're headed that direction. What I want to shift towards a little bit too is I know we're talking infrastructure, but the idea is that, we're thinking about a data first strategy. Is that we've always thought about this from an infrastructure standpoint, right? It's what box does it live on? How do we manage it? Permissions were almost tied to these silos. And then the data scientists and the rest of the world, the BI community, right, comes from a file context side. They're pushing from, hey, I want to tag this and catalog it. And half the data scientists I talk to don't really understand the storage they're on, or they don't want to have to know about it. Even in my career early, I did all SQL optimization. I learned RAID backwards. I was like, what is this Dell thing? What's a RAID group? Why is my temp DB slow? And so the idea being is that there were always kind of 2 halves to this AI super brain. And so part of what we're doing in this data platform is not only taking the best of Hammerspace and the best of NVIDIA, but, partnering with people like Secuvi or Varonis or these other companies that are really good at data categorization and tagging, right? We feel like the vision, right, that we're really trying to push out of there is that the security, the performance characteristics and stuff aren't tied to where the data lives, right? We've always dealt with where data is born. And it's always been very heavy and very expensive to move. But, data gravity has always been a thing. Now we feel like GPU gravity is a thing, and it's really power gravity, right? It's like, who's building the next nuclear reactor and who's going to put the 100 megawatt data center right beside it, right? And so it's this idea of how do we eliminate the data gravity challenge? There are times that we need to move it. We want to avoid that at all costs because it's expensive. There's ingress charges, egress charges, fiber's not cheap, right? But we think more about the high fidelity data pipelines, how we evaluate quantity, right, over quality, the proactive governance, right? And Amir, and you kind of asked these questions too. It's like, well, what if that followed the data? What if we could store that in metadata? And it wasn't that we relied on just the file system, but what if that was attached almost as an attribute to that particular piece of data? And then this is really about time to value, right? There is an AI race that's going on. And so, we've got some statistics to show how long it takes to cobble all this together in most enterprises versus buying a solution like this that really can get you up and running within weeks of hardware delivery being on site. Real quick, I'll show you a little bit of the demo. We talked about MCP, some of those types of things. To me, this is the glue, right? This is the new agentic workflow. We used to care about service accounts and all these different things, and now we're talking about agent security. And we've got father agents and mother agents and child agents and all sorts of things. But what I want to give you a preview of, right, is how we're trying to make this human interactable, right? Is we don't want to have to think about NV ingest and pushing massive JSON files. But in this, what you see is we're actually asking this thing to build and execute a plan that uses the product launch update data bill of materials that's inside Sukuvi, right? So this is a pre-validated data bill of materials that's been scanned for PII, anonymized, approved by the security team to be used, that will validate, ingest, and clean up the data using AIDP cluster 1, because we realize that there may be more than one of these on-prem in the cloud, to a specific vector database and complete logging and everything, right? And so, on this interface, you see we're discovering files on the right-hand side, but what this does real time is builds and executes a full plan. How many files? Do they need to be moved? Can I do it in place? We're using metadata properties about performance and security to make intelligent decisions that usually would take a data scientist just saying, rsync this directory, let me go get coffee, and I'll come back 2 hours later when that particular job's finished. So you can see we do everything from full testing and validation throughout this entire process. Everything we're doing, I learned a new term, right? We used to talk about eating our own dog food. Drinking our champagne sounds much more elegant. But this is what we're doing now, is that we're tracking every single micro millisecond move of data across the file system into these particular workflows, fully diagrammed. Because what we found is most of our customers are using some script on one monitor, copying, pasting it on the other, and hoping all this came together. So for us, it wasn't just about can we stitch it together, but as a platform, it's how do we integrate with third-party security tools? How do we make sure we can diagnose and debug these workflows incredibly quickly? And if we're going to be that platform to own and manage everything, we have to expose all of this from a data standpoint. So I'll wrap here. We can talk through a few questions, but again, this idea is that we're bolting this on to existing systems. This isn't a buy new and migrate to, which we saw most of our competition pushing, right? Copy it to my shiny new Flash platform, and then we'll do the magic. We really want to help enterprises start where they are. How do they build the AI factory with the existing capital investments they've made? Again, we talked about time to value. Below this Fortune 500 magic line, there's not all these AI centers of excellence and AI tiger teams and this sort of stuff. It's John, who's been running storage forever, and 2 or 3 data scientists from marketing and product who are trying to stitch this together. And so we're trying to create a solution that we can add on to an existing Flex pod or existing, Isilon stack or whatever we need to do to really help them take control of their data, rein in that chaos, and get AI ready data in weeks.